Okay, let's knock these last ones out on 8.1. On Thomas's, I cut early. My earbuds did something weird, and it cut out the last two problems. If you need help on those, let me know. My guess is you won't. I'd already shown you 4 ways, or 4 of the first 4. Okay, write the first 4 terms. Number 1 is a sub n equals 7 times n plus 3. So a sub 1 is 7 times 1 plus 3. That's 7 plus 3, that's 10. A sub 2 is 7 times 2 plus 3, 7 times n. 7 times 2 is 14, so that gives us 17. A sub 3, 7 times 3 plus 3. 21 plus 3, that's 24. And a sub 4, 7 times 4 plus 3, so we get 31 out of that. Number 2, same thing. Let's come up with the first 4 terms here. Negative 11 to the n power. So a sub 1 will be negative 11 to the first power, which is just negative 11. A sub 2 is negative 11 to the second power, which is 121. A sub 3 is negative 11 to the third power. Use your calculator. Be sure you're putting negative 11 in parentheses. Raise it to the third power. You'll get negative 1331. And a sub 4 is negative 11 raised to the fourth power. Parenthesis, negative 11, close the parenthesis. Raise it to the fourth power. Positive 14641. Number 3, you've got a sub n equals 2 times n over n plus 12. We're coming up with the first 4 terms of that also. So a to the first is 2 times 1 over 1 plus 12. That equals 2 over 13. A sub 2 is 2 times n, in this case it's a 2, over 2 plus 12. That gives you 4 over 14, which reduces to 2/7. A sub 3 is 2 times 3 over 3 plus 12, 6 over 15, which reduces when you divide by 3 to 2/5. If you're not sure, use your calculator. Let me remind you, 6 ABC 15 will reduce to 2/5. And a sub 4, we got 2 times 4 over 4 plus 12, 8 over 16, which reduces to 1/2. Number 4 and 5 are asking you for the following recursive formulas. These are closed formulas. We could go after any one that we wanted to and easily plug in and come up with the number. These next 2 are recursive formulas, which means they're going to have to give us a head start on this. So a sub n equals a sub n minus 1 plus 8. This is the previous number. We need a starter. A sub 1 is 13. So when we go and do a sub 2, we're looking for a sub 2 minus 1, which is so we've got a sub 2 minus 1 plus 8. This a sub 2 minus 1, that's a 1. So you're grabbing the previous answer and adding 8 to it. And so we get 21 out of that. So a sub 3 is going to be a sub n minus 1, which is 3 minus 1. 3 minus 1 is 2. So you're grabbing the previous answer. A sub 2 is a 21 plus 8. That gives us 29. A sub 4 is a sub 4 minus 1 plus 8. 4 minus 1 is a 3. So we're finding the previous answer, 29 plus 8, and getting 37. So we've got 13, 21, 29, and 37 as our answers. Number 5 is also recursive. Oh, you couldn't see that. You could see down to, where are we here? Sorry about that. So we're grabbing the previous answer each time. I think we did this one. Sub 3 minus 1, that's a 2. So you're grabbing the previous answer, 21, and adding 8 to it. A sub 4 is 4 minus 1, that's a 3. Grab the previous answer and add 8 to it. Number 5 The recursive formula, which depends on you then being able to go back and grab the previous answer, looks like that. For any particular number we need, we're going to have to go grab the previous answer, multiply it times 4, and add 1. When you're looking at a sub 1, there is no previous answer, so they have to spot you that one. There we go. So a sub 2 is going to be 4 times a sub 2 minus 1 plus 1. That'll give us a sub 1 there, so it'll be 4 times the previous answer plus 1. That'll give us 21. A sub 3 is 4 times a to the sub 3 minus 1. That's a 2. So we're going to go 4 times the previous answer, 21, plus 1. This gives you 84. One more gives you 85. And a sub 4 will be 4 times a sub 4 minus 1 plus 1. This is asking you to go after the previous answer, so 4 times 85 plus 1. That's 340 plus 1. We'll get a 341 out of that. 4 times 85 plus 1. Number 6 is giving you another closed formula, but you're going to use some factorial in there. So number 6, a sub n equals n to the 5th power over n minus 1 factorial. It's a closed formula. Find the first 4 terms. So a sub 1 will be, put in the n, 1 to the 5th power over 1 minus 1 factorial. 1 to the 5th, 1 times 1 times 1 times 1 times 1. And then 1 minus 1 is 0. Remember that little trick. 1 factorial is a 1. It doesn't seem like it should be, but that's what you're stuck with. A sub 2 will be 2 to the 5th on top, 2 minus 1 squared on bottom. 2, 4, 8, 16, 32. So we've got a 32 on top. 2 minus 1 is 1. 1 factorial is just 1. So we get a 32. A sub 3 is going to be 3 to the 5th power over 3 minus 1 factorial. 3 to the 5th, I think, is 243. Let's check it out. 3 humpy 5 is 243 over 2 factorial. So 243 over 2 times 1, which is just 2. So it's cutting 243 in half, divided by 2. We get 121.5 there. 121.5. Yeah, you barely got that, huh? Or not quite. But I told it to you. A sub 4 is going to be 4 to the 5th power over 4 minus 1 factorial. 4 humpy 5 will give you 1024 over 3 factorial, so 3 times 2 times 1. This is 6, so we're doing 1024 divided by 6 and getting 170 round to the nearest hundredth. So 170.67. Number 7 is a factorial problem. 6 factorial over 4 factorial. Let's expand that out. 6 times 5 times 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1. Those will cancel. 6 times 5 is 30. Number 8 is writing out the summation. Evaluate these summations. So we're going to have to add them up. So let's look at what we've got here. Initial is 1. Upper limit is 6. And we're doing 12 times j for each one. So the first term, when j equals 1, we're going to do 12 times 1. When j equals 2, we're going to do 12 times 2. When j equals 3, we're going to do 12 times 3. When j equals 4, we're going to do 12 times 4. When j equals 5, we're going to do 12 times 5. And when j equals 6, which is where we're stopping, we're doing 12 times 6. So the summation is 12 plus 24 plus 36 plus 48 plus 60 plus 72. Add that up on your calculator. 12 plus 24 plus 36, 48 60, and 72, and getting 252. Yes, 252, which happens to be the punchline of a George Carlin skit, but you probably don't know it. Number 9, we're doing the same kind of thing. Let me scoot us down. Number 9 is a summation. We're going from where I equals 3, our upper limit is 8, and what we're doing to each number is just making it 16. So when I equals 3, the answer is 16. When I equals 4, the answer is 16. When I equals 5, the answer is 16. When I equals 6, when I equals 7, when I equals 8. So 1, 2, 3, this is when I equals 3, 4, 5, 6, 7, 8. We've got them all in there. 1, 2, 3, 4, 5, 6 times 16. 6 times 16 is 96, and that's the answer. So this is the expanded form, and that's the answer. And finally, they want us to do the opposite of that on number 10. So let's look at number 10. Build your own little summation guy, and they'll have that on my math lab for you. K equals or I equals or J equals, you choose, although they'll have that one set up for you. The initial number here is a 1, and our end partner little guy is an 18. And what are we doing each time? We are taking each of those K's and squaring them. So there's your answer. We're good. See you next time.